Hello everyone, I hope you all are fine there. So in today's session, we will discuss about angle of arrival and angle of departure. This is a nice concept, and generally maximum students solve this angle of departure and angle of arrival. They apply some formula. They don't know from where this formula came. So actually in this session, I will tell you from where this formula came. And actually we will not discuss about formula, we will try to discuss about the concept, and based on the derivation itself, we will try to solve the problem. It means we will not apply any formula, we will apply to concept to solve a problem, okay? And you will understand what is the meaning of angle of arrival and angle of departure, okay? So this topic is taught in control system, so it's a control system topic, and you can say this topic is taught in root locus, okay? So let's discuss this angle of arrival and angle of departure concept. So this session is coffee with concept, and I hope you are enjoying these sessions, coffee with concept, because in this session we will try to, in this coffee with concept series, we try to concise the lecture, okay? So within 15-20 minutes, we will try to discuss this topic, okay? So let's start. This is my introduction. So I teach almost every subject. My name is Asu Jangda, and I hope you are enjoying my sessions. Now, let me tell you guys, those students who want to get some scholarship, they can get the scholarship, they can enroll for the scholarship test. Now, since I'm recording this session on 28th, so it might be possible that you are watching this session after 28th. So you can register for the next scholarship test, okay? Every week there are scholarship tests, so you can avail scholarship up to 90%. So you have to register for that. The link is given in the description of this video. Don't forget to subscribe our channel and press the bell icon so that you get notification whenever my sessions are there, and press the like button. This is Guru Dakshina. Okay, so let's first discuss about angle of departure. Now, what is this angle of departure? What is this angle of departure? If you look at the angle of departure, then let's say there is an open loop transfer function GSHS, and GSHS is given as K divided by S plus 2 into S square plus 2S plus 2, let's say, okay? So this is my open loop transfer function GSHS. Now, if you look at this, there are 3 poles and there is no 0. One pole will lie here at -2, and the 2 poles will lie, one at this position, one at this position. It means there are 3 poles, and these 3 pole locations are shown in your figure. This is -1 plus J1, and this is -1 minus J1, okay? Now, we know that if you plot the root locus, then you need to satisfy the Ivan condition. Now what are those Ivan conditions? The Ivan conditions are, Ivan conditions came from the characteristic equation itself. It means 1 plus GSHS equal to 0. This is my characteristic equation, okay? From here I can say that GSHS is equal to -1. Okay, so from here you can derive Ivan condition. So the first Ivan condition is the magnitude of GSHS has to be 1. The magnitude of GSHS has to be 1, and the second Ivan condition is the phase of GSHS. Since it is a negative number, so the phase has to be odd multiple of 180. Okay, 2q plus 1. This is an odd number. 2q plus 1 is odd number into 180. Now you can take it plus or minus, it doesn't matter, okay, whether you take plus sign here or minus sign here. So these are the Ivan condition. On root locus, these 2 conditions must satisfy. On root locus, at every point, these 2 conditions must satisfy, especially the phase condition. So in angle of departure, we will look at the phase condition only. Now you can see that these are the pole location for this system for k equal to 0. If k is equal to 0, then the closed loop system pole will lie at this location. Now, first of all, let's look at the real axis. Which part of the real axis will be the part of root locus? You can see that this side will be the part of root locus, but not this side. This side will not be the part of root locus. Now, you have 3 poles and there is no 0. So all these 3 poles have to terminate at infinity. It means they should go to infinity. They must go to infinity. If you increase the value of k, then the closed loop system pole will change. If you are increasing the value of k, closed loop system pole will change and they will go to infinity. But on which side they will go to infinity? At what, you can say at what angle they will go to infinity? For that, I need a centroid point and asymptotes. So the number of asymptotes are, you can see that the number of asymptotes are, 3, because we know that there are 3 poles, no 0. So all these 3 poles have to go to infinity. We know that. Okay. And the centroid will be equal to sum of pole minus sum of zeros. So if you take the sum of poles, then you can say that the sum of pole is -4 minus sum of zeros, there is no 0, divided by number of pole minus number of zeros. So -4/3 somewhere here. Okay, this is my centroid point. So you got the centroid point minus 1.33. Okay, sum of pole minus sum of zeros. Now angle of asymptotes. If you look at the angle of asymptote, it will be 180 divided by 3 into 2q plus 1. 180 into 2q plus 1 divided by number of pole minus number of zeros. Okay, and q varies from 0 to p minus z minus 1. It means up to 2. You know that p minus z is 3, p minus z minus 1 is 2. Okay, so you can put the value q as 0 and then 1 and then 2. So you will get 60 degree, 180 degree and 300 degree. So you will get 3 angles, 60 degree, 180 degree and 300 degree. Now let me show you these asymptotes. So one asymptote will be at you can see that this is at 60 degree. One is at minus 60 degree and other one is at 180 degree. These are the asymptotes. It means they have to go to infinity along these asymptotes. So this pole is already moving along the asymptotes. You can see that this pole is already moving along the asymptotes. It is already moving on this side. So it is already moving asymptote. Now these two poles have to go towards this asymptote. But the problem is at what angle they will depart here. What should be the angle of departure here? That's why we need to calculate the angle of departure, because we don't know at what angle they will depart. They will depart like this, or they will go like this, or they will go like this, or at what angle they will depart at this point. So we need to calculate the angle of departure at this point. Now how to calculate angle of departure? It's very simple, guys. It's very simple. You don't need to remember anything. What concept you can apply to calculate angle of departure? Let me redraw this. Okay, so these are the location of the pole. Now we need to calculate the angle of departure at this point. It means in which side the root locus will move. So what we can do is we can assume that there is a point P which is close to this pole. Let's take a point P which is very close to this pole, and this P lies on root locus. Okay, P lies on root locus. It means P must satisfy these Ivan conditions, especially this phase condition. Okay, so we are assuming that this P point lies on the root locus and it is very close to this pole, Now if P lies on root locus and if it is very close to this pole location, it means we can calculate the angle of departure. How? We know that if this is very close to this pole and if this point lies on the root locus, then the root locus will move towards this side. Simple. It means you can check if there is a point P which is in the neighborhood of this pole, and the point P should also lie on the root locus. If this point P lies on the root locus, it means after this pole, if you change the value of K, the root locus will move towards this P because P lies on the root locus. So if somehow you can calculate this P, or somehow you can calculate this angle, at what angle this P point will lie, that angle itself is known as angle of departure. Because we know that the P point is very close to this pole and it lies on the root locus. It means the root locus will move towards via this P. Root locus will move via P. If the root locus move via P, It means this line will tell you about the angle of departure. Now that angle we need to calculate. How to calculate this angle? It's very simple. We know that this point P lies on the root locus. If this point P lies on the root locus, then you can say, if this point P lies on the root locus, wait a minute. If this point P lies on the root locus, then you can say that this point P must satisfy the Ivan condition, especially the phase criteria. It means at this point P, the phase of GSHS has to be minus 180, odd multiple of minus 180. Now, how to calculate the phase of GSHS at this point P? Phase of GSHS at point P. How to calculate that? It's very simple. We know that GSHS is this, K divided by S plus 2 into S square plus 2S plus 2. There are 2 points. Either you, in place of S, you put the value of S equal to P and calculate the phase and equate it to minus 180 because P lies on root locus. This is one point, but the problem is we don't know P. So this way you cannot calculate the angle. There is one more way to calculate the phase of GSHS at this point P. How to calculate? It's very simple. What you can do is you can take these lines, okay? You can take these lines. At this point P, you draw these lines, okay? Let's call this as phi 1, phi 2, and this line is making an angle. This line which is connecting this pole and the point P, this line making an angle phi 3 with the positive horizontal axis, okay? With the positive horizontal axis. Fine. So what you can do is at this point P, if you want to calculate the phase of this, then the phase of this has to be angle due to zeros, angle due to numerator minus angle due to denominator. Because since whatever the angle of the denominator is, that will come in the numerator and we have to change the sign. It means it will be negative. Angle due to zeros minus angle due to poles. Angle due to poles. Okay. This will be the phase of GSHS at this point P. Now what is the angle due to zeros? There is no zero. So it means you can see that the angle due to zeros is 0 minus angle due to pole. So the angle due to pole is phi 1 plus phi 2 plus phi 3. So this is the phase of GSHS at this point P. Now how to calculate angle of GSHS at point P? We can draw these lines from all the poles to this point P and calculate the angle of these lines. How much angle these lines are making with the positive horizontal axis. That is the angle due to poles. Similarly, we can calculate the angle due to zeros, but in this particular question, the angle due to zeros is 0. And the angle due to pole is this. And this phase has to be minus 180 or odd multiple of minus 180. Now, if you look at this carefully, we need to calculate this phi 3. This phi 3 will be called angle of departure. This will tell you about angle of departure. This will tell you about angle of departure. Why? Because we know that this point P is very close to this pole. So if you increase the value of K in GSHS, the root locus will move towards this P. It means if you know the angle of this line, you know the angle of departure. So this phi 3 itself will show you the angle of departure. We need to calculate this phi 3. To calculate this phi 3, we must know phi 1 and phi 2. What is this value of phi 1 and phi 2? How to calculate these values? It's very simple. We know that this pole lies very close to this P point lies very close to this pole. If the P point lies very close to this pole, so what we can do is phi 1 is nearly equal to the angle of this line, because we know that this P and this pole is very close. If P and this pole are very close, you can assume that the P is exactly at this pole, exactly at this point P. If I am assuming that this P is very close to this pole, then you can say that phi 1 is this angle. Phi 1 is this angle. You can assume that this angle is phi 1 itself. Okay? And you can see that this angle is 90. And phi 2 is this angle. Phi 2 is this angle. Actually, phi 1 and phi 2 has to be measured from P point. Has to be measured from P point. But P is very close to the pole location. So we can use approximation. Okay? we can use that phi 1 is the angle due to from this pole to this pole, okay, and phi 2 is angle of this line from this pole to this pole, okay. Now we know that this phi 1 has to be 90 degree and phi 2 has to be tan inverse of this perpendicular length upon this length, okay. So this length is 1, this length is also 1, okay, so it is 45 degree, fine. So we know this phi 1, phi 2. So now in this case also phi 1 and phi 2 are exactly near about same because P is very close to this pole. So we found phi 1 and phi 2. If you find this phi 1 and phi 2, you can easily calculate phi 3. So phi 3 will be equal to minus 180. This is 90. Okay. So since it is minus here, so it will go on the right side. It will become plus 90 and plus 45. Okay. Now you can see that the answer is minus 45. Phi 3 is minus 45. This itself will tell you about the angle of departure. So you don't need to remember any formula. You don't need to remember any formula. You need to understand the concept, how to calculate the angle of departure. So this is the angle of departure. It means at this point, if I want to calculate the angle of departure, let me rub this so that I can tell you about the angle of departure. Okay. So we have calculated that the angle of departure at this point is minus 45 degree. So what we can do is, now one pole was here, one pole was here, one pole was here, and we know that the asymptotes are like this. These are the asymptotes. So now we know that the angle of departure is minus 45 degree. So this pole will come downward and ultimately it will go this side. Okay. Similarly, symmetrically, you can see that this pole will go like this. Okay. So you can plot the graph like this. At this point, you can calculate the angle of departure with this concept. Okay. You don't need to remember any formula. Okay. But remember how to calculate the phase of GSHS at some point. At some point P, the phase of GSHS is, you can take the zeros, angle due to zeros, because zeros are in the numerator. So angle due to zeros at this point P minus angle due to pole. In this particular question, there is no zeros. Okay. So only angle of poles are there. And how to calculate these angles, you should understand that. Okay. And now this phi 3 itself will tell you about the angle of departure because it's very close to this pole location. I hope you got the idea. I hope you understood it. Similarly, you can calculate the angle of arrival. In a similar way, you can calculate the angle of arrival. Okay, let's take a question. Let's say I have GSHS. Let me take a question. Okay, let's say GSHS is equal to K into S square plus 2S plus 2 divided by S square plus 4S plus 8. Okay, let's say this is the question. Now in this question, you can see that the zeros will lie here. Zeros will lie here. Minus 1 is the real part and the imaginary part is J1. Okay, this location is for zeros, J1. Fine. Now, where the pole will lie? The pole will lie at this location, minus 2 plus J2. This is the pole location. Okay, J2. Now we know that if you increase the value of K, it will go like this. I mean, the rough graph is like this. It is a rough graph. This is the root locus. You can easily plot. But the problem here is, we need to calculate what is the angle at which it will depart and what is the angle at which it will arrive. So we require angle of arrival also. We require angle of arrival and angle of departure. Angle of departure. So let's try for angle of departure. So what we can do is, we can apply the same concept that we have done previously. Okay, and let me rub this because there is no need for that. Okay, yes. Now you can assume that let's first calculate the angle of departure. So at this point P, let's imagine that this point P is very close to this pole location. Okay, and it lies on the root locus. If it lies on the root locus, then the angle of GSHS at the point P has to be minus 180 according to Ivan conditions. Because I am taking that feedback is negative, so negative feedback, this angle has to be minus 180. Now what you can do is, at this point calculate the angle due to zeros, angle due to this zero. So this is the angle due to this zero, let's call it theta 1, and angle due to this zero, let's call it theta 2. Okay, angle due to zeros, that is theta 1 plus theta 2 minus angle due to pole. So angle due to pole, angle due to this pole, okay, angle due to this pole, let's call it phi 1, and angle due to this pole, let's call it phi 2. This angle is phi 2, okay. So minus phi 1 plus phi 2, this has to be minus 180. This is the phase of this GSHS at this point P. Now this phi 2 will tell you about angle of departure. Angle of departure. Okay. This phi 2 will tell you about angle of departure. We need to calculate this phi 2. Now how to calculate this theta 1, theta 2 and phi 1? It's very simple. We know that this point P is very close to this pole location. If it is very close to this pole location, why you are tilted this? I mean, you can directly connect this line to this pole, this line to this pole, this line to this pole, and you can calculate directly. If you can connect this point P, if you take this point P very close to this pole location, then you can say that this theta 1 has to be 135. This theta 1 has to be 135, okay? So theta 1 is 135. You can directly calculate theta 1 as 135. And this phi 1 has to be 90. Phi 1 has to be 90. And theta 2 will be equal to tan inverse of. You can connect this point, and we know that this perpendicular length is 3 and this horizontal length is 1. So tan inverse 3 by 1 is this angle. So pi minus tan inverse of 3 by 1. Okay. Write it again. Theta 2 is pi minus tan inverse of 3 by 1. This is my theta 2. Now what you can do is, you can put these values and calculate this phi 2. This will be the angle of departure at this point, at this pole location. Now what is the angle of arrival? In the same way, you can calculate the angle of arrival. Same concept, okay? So in angle of arrival also, let me redraw this. I mean, you can same way, you can apply the angle of, this is not the, wait a minute, these are the zeros, okay? So here the zeros and the pole location will be at this position, fine. Now how to calculate angle of arrival? Angle of arrival can be calculated in the same way. You can assume that this point P lies on root locus. At this point P, the phase of GSHS, has to be equal to minus 180. We know that. Now how to calculate phase of GSHS at this point P? Angle due to zeros minus angle due to pole. So angle due to this zero is called, let's call it theta 1, okay? So theta 1 plus angle due to this zero. Angle due to this zero is, let's call theta 2 minus angle due to pole. Angle due to this pole is called phi 1, okay? This is phi 1. And angle due to this pole, I am measuring this angle from the positive horizontal axis. Let's call it phi 2. This is phi 1, okay? So phi 1 plus phi 2. This is angle due to pole. That has to be minus 180. Now the angle of arrival is theta 1. We need to calculate this angle theta 1. Because we know that this P point lies on the root locus. If it lies on the root locus, it means at this 0, the root locus will come via P. First it will reach to P and then it will reach to 0. It means this line, whatever the angle this line is making with this positive horizontal axis, that will be the angle of arrival. We need to calculate this theta 1. Now to calculate theta 1, we need to find phi 1, phi 2 and theta 2. Now how to calculate phi 1, phi 2 and theta 2? That you can calculate easily. We know that this P point is very close to this 0. So what we can do? We can assume that this P point is very close to this 0, and then we can draw the line. This line will be exactly here, this line will be exactly here, this line will be exactly here. So with respect to this 0, you can calculate this angle. It's just an approximation you are taking, okay? So if you are taking that this P point is very close to this 0, then you can say that theta 2 has to be 90. This angle will become 90, and this phi 2 will be minus 45 degree. Phi 2 will be minus 45 degree because you know the position. You know its position, and you can calculate this angle with the help of geometry. And this phi 1 will be tan inverse of this vertical length divided by this horizontal length, because it will make a right angle triangle, okay? So 3 by 1, fine. So we know this theta 2, phi 2 and phi 1, we can put these values and we can calculate this theta 1. Theta 1 will tell you about angle of arrival. This will be the angle of arrival, okay? So it's the same concept, it's the similar concept, nothing new. Only one concept is used and there is no need for any formula. If you know the concept, you can directly apply that concept to calculate the angle of departure and angle of arrival. Generally, students remember this formula. I mean, if you have understood the concept, no need to cram this, okay? Just understand how to calculate the angle of GSHS at some point P. That angle is angle due to zeros minus angle due to poles. Simple. So I am calculating the angle at some point P and I am applying the Ivan condition, nothing else. Since this P is very close to this zero, so we can calculate these angle with respect to this zero only, okay? That is approximately equal to this angle, okay? Let's say this angle is 90. So this angle is also 90 because though in the figure it is little bit of shifted away, but actually it is very close. So that angle is almost 90, okay? So with this help, you can calculate the angle of arrival also. I hope you understood these concepts, angle of departure and angle of arrival. Don't try to cram this formula. This was the difficult concept that students feel because they need to remember this formula and they feel difficulty in this. Okay, so don't feel difficult, guys. It's a simple concept and you can apply this concept like I have told you. So don't forget to subscribe our channel and like this session, press the bell icon. There is one more important notification, important information, that is we have our mobile app, BYJU'S Exam Prep. Go to the Google Play Store, install this mobile app. There also you will find free lectures and I am also taking free lectures there on the mobile app, so you can enjoy those lectures also. And I am telling you the small tricks, how to use the direct method, how to use trick in these particular questions, okay? And how to use the options to calculate the correct answer, okay? So those things I am taking on the mobile app, so please install this mobile app and watch my session on mobile app also. That's all for today's session, guys. Thank you and see you in the next session. Thank you. Bye.